Hi everyone, Miss Soli here with geometry. Go ahead and open up to your table of contents. Today we are talking all about conditional statements. Conditional statements. So open up to that next blank page, 1.5 conditional statements. All right. So a conditional statement, if then. If then. A conditional statement is a two-part logical sentence. It goes like this. If hypothesis, then conclusion. If it's raining outside, then I will wear my rain jacket. If I watch this lesson, then I will learn about conditional statements. So I've got a hypothesis and a conclusion. If, then. It has to have those two words in there. If, then. So for example, if I have a random statement like all birds have feathers. This is not a conditional statement because it does not have an if, then format. But to turn it into a conditional statement, I could say something like, if it's a bird, then it has feathers. And I've got my hypothesis here and my conclusion here. If it is a bird, then it has feathers. Okay. And then the next, lots of sentence structure today. I could also have what's called a negation. Negation, negate, to undo, to not something. It's the opposite of the original statement. Eek. So for example, if I said, the ball is red. Here's where negation sometimes gets a little tricky. A negation would not be, the ball is blue, because blue is not the opposite of red, right? The opposite of red is the ball is not red. So you can't just say, okay, it's something else. A negation is like clear 100% opposite of the original statement. Another example, if I had, the dog is not happy, the negation of that, a negation of something with a not in it, it would turn into the opposite. The dog is happy. So negation, opposite. Whatever it is, opposite of that. Red, not red. Not happy, happy. Okay. Now, I can take my conditional statement, and there are 4 different types of kind of forms of that conditional statement. So I've got my conditional, and this is going to kind of be like one big example. Got your conditional statement, and I'm going to do this in terms of an example we can kind of understand and talk about. So a conditional statement could be like this. If you're in Minnesota, then you're in the USA. Okay, so your hypothesis in this case is going to be you're in Minnesota. That's like the first bit. So if you're in Minnesota, then you have to be in America because Minnesota is part of America. So if you're in Minnesota, then you are in the USA. We do have a shorthand for this. If P, then Q. And we even take it shorter because mathematicians love a shortcut. P, arrow, Q. This is my starting point. This is my conditional statement. A converse to the conditional statement is going to reverse. Reverse the order. So a converse statement would be if you're in the USA, then you're in Minnesota. Now I want you to think about that for a second. If you're in America, then you're in Minnesota. Is that true? No. If you're in America, you could be in New York, you could be in California, you could be in Colorado. It's not necessarily true that you're in Minnesota. So a converse statement to the conditional is not always true, but this is a converse. Again, I can have my shortcut. This is going to switch these two. If Q, then P. Q, then P. Converse, reverse. Next, I have an inverse. And what this is going to do is negate both. It's going to negate both of these pieces. So I'm going for my original conditional statement then. If you're not in Minnesota, then you're not in the USA. If you're not in Minnesota, then you're not, then you're not in the USA. Is that true? If you're not in Minnesota, you could be in Iowa. If you're not in Minnesota, then you're not in the USA. No, that is not a true statement. These are false. Sometimes. If your conditional statement is true, then these two sometimes are false. But that is still an inverse of it. So this would be if not P, then not Q. The symbol for not is like a little squiggle. Not P, not Q. Now the last one, and the fanciest of all of these four pieces, my favorite, is the contrapositive. Contra, I see that word in kind of like in contradict. To contradict something is to like disagree with it or opposite it. So a contrapositive is both a negate and a reverse. Negate and reverse. Okay, so it's going to look like this. If you're not in the USA, then you're not in Minnesota. So notice my hypothesis is now over here. My conclusion is now over here, and they're both negated. Okay. Is this true? If you're not in America, then you can't be in Minnesota. If you're not in the United States of America, then you cannot be in one of the states. True. This is a true one. If not Q, oops, then not P. Not Q, then not P. So these two, conditional and the contrapositive, these two are true. And so that's going to be, they're kind of related. Now, if all four of these things are true, then I can write something called a biconditional. Biconditional, bi meaning two, would be like my argument can go two ways. It can go both ways. If the conditional and the converse are true, if conditional and converse are true, and if these two are true, then that does automatically mean that these two are true. Like the converse and inverse, they're going to be the same truth value, and conditional and contrapositive will be the same. Are true, then you can write this. Hypothesis, if and only if. Conclusion. So your hypothesis, if and only if. Conclusion. And there are a couple of symbols for this. It would look P. Sometimes you can write it IIF. No, IFF. IFF. If and only if. Q. You can also write it with an arrow going both ways, meaning if P then Q, and if Q then P, if the conditional and the converse are true. So one example of this is usually like using a real definition. So let's say if two lines cross at 90 degrees, then they are perpendicular. I'm going to use this symbol for perpendicular. 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 If the two lines cross at a 90 degrees, then they are perpendicular. That's true. Let's check if the converse is true. If two lines are perpendicular, then they cross at 90 degrees. Also true. If they're perpendicular, they cross at 90 degrees. So because my conditional, if P then Q, and my converse, if Q then P, are both true, now I can write a biconditional. My bicon. Two lines cross at 90 degrees if and only if they are perpendicular. Remember, this means if and only if they are perpendicular. So usually biconditionals, you can use that for definitions. Thanks, everybody.